Welcome to a lesson with Dr. Powell. Okay, let's have some fun and talk about binomial coefficients and Pascal's triangle. All right, so this is a way of thinking about what x plus n or x plus 1 to the n is, where n can get large. Well, at least when we draw things out, we'll keep things fairly small. Okay, so what do we do? Well, first of all, let's just think about multiplying using the normal multiplication type algorithm. So we can multiply where we're thinking of this as being x plus 1, but I only wrote the coefficients down. And let's think about this as, first for starters, this is x plus 1 squared. So I'm multiplying x plus 1 times x plus 1. If I multiply the 1 to each thing, that's nice. It's just the same thing. If I multiply x, it shifts everything over the power of x. So this is like constant, this is like x to the first, this is like x squared. Go ahead and add 1, 2, 1. All right, let's do it again. Let's multiply again. 1, 2, 1. Oh, it just shifts over. Add again. 1, 3, 3, 1. All right, let's do it again. Let's see. 1, 3, 3, 1, 1, 1. Get 1, 3, 3, 1, 1, 3, 3, 1. Then we add 1, 4, 6, 4, 1. And we can keep going, but notice how to move from one line to the next. Notice that this moves down here and adds with that. It's kind of like just adding adjacent things like 1 and 3. Or right here, 3 and 3 add together, but that's like taking this 3 and putting it here. Oh, 3 plus 3 is 6, and it's like adding 3 and 3. And similarly, right here, this 1 and 3 can be thought of as 1 plus 3 over here. So we could actually think of this in one line. So think about the line 1, 3, 3, 1, and how do we move to the next line? Well, we could think of saying 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and just putting ones on the ends. This is the mechanics of Pascal's triangle. Pascal's triangle starts with a 1 on the top, then moves 1, 1, 1, 2, 1. This is be like x plus 1 to the 0th power, x plus 1 to the first, x plus 1 squared. 1, 3, 3, 1, 1, 4, 6, 4, 1, and you could keep on going. 1, 5, 10, 10, 5, 1. These numbers right here are called binomial coefficients. They're the coefficients of this binomial raised to a power. They take on a special notation or name. So if we think about x plus 1, maybe to the 5th power, the coefficient that goes in front of the x cubed, we notate like this, 5, and we say choose 3. Because what we're doing is we're taking the 5 factors, x plus 1, x plus 1, x plus 1, x plus 1, and x plus 1, and we are trying to see how many different ways there are of choosing 3 x's from amongst these 5 factors. So among the 5, choose 3 of them to give you x. Because essentially what's happening when we're multiplying is we're taking all possible ways of taking something from here, times something in here, times something in here, times something in here, times something in here. So all the different ways. And then we list all those out, and then we combine like terms. Well, let's think about like terms. X cubed. X cubed happens from choosing 3 x's. So that means 3 of the factors you choose x from, and 2 of them you choose 1 from. So this would be the coefficient 5 choose 3. Now, if you want to figure out what 5 choose 3 is, you could use Pascal's triangle. Or you can think of the following. X plus 1 to the fifth is equal to something, and then you add what you're after, I'll call it c times x cubed plus other things. So, well, what happens if you take three derivatives? You're going to get 3 factorial. You're going to get 3 factorial times c as your constant term plus other things. Over here, using the chain rule, you're going to have 5 times 4 times 3 times x plus 1 squared. Okay, notice what happens when you plug in 0. All that goes away, and this becomes 1. And c you can get by dividing over. It's 5 times 4 times 3 over 1 times 2 times 3. This would be 5 choose 3. Notice there's 3 factors on the bottom, 3 factors on the top. On the top, you start at the top. On the bottom, you start at the bottom. And you do 3 up, 3 down. Not more than that. So 5 choose 3 is simply calculated in this way. Likewise, 5 choose 2 is 5 times 4 over 1 times 2. 2 factors, top and bottom. Now, you'll notice if you calculate these two values out, they will be the same. They're both 10. And that's because it should be equivalent. Number of ways of choosing 2 1s and 3 x's. I mean, it's symmetric. It doesn't matter if you chose 1 or x to be what you were talking about. The same idea is true even if we did x plus y, replacing the 1s with y. It still works. And the coefficient of x cubed y squared would also be 10, as well as x squared y cubed. It's very symmetric, which can be seen in the triangle. When we get down to that line, remember we had 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. By symmetry, with 2 plus 3 being 5. So that's what a binomial coefficient is, and that's where it comes from, and that's how we can think about it. Thanks for watching.